Record.
Great. Good morning. Good morning, all. Let me switch to gallery view here. I see all of you. Great, great. Okay, we'll wait for other people to turn up. Okay, so there's a bunch of you here, but I think there's usually more people. So we will actually let me change my glasses to this time so that when you guys start coding, it'll be easier. All right, that's a whole lot better. Okay, awesome. Okay, well, you know what? You guys should continue to talk amongst yourself just until more people join in. I'm pretty sure they will in about 5 or 10 minutes. So just go ahead, talk to each other. You can ask Walter questions, but hopefully don't ask Walter questions until the class actually starts, because this time, the time before class starts, mainly meant for you guys to catch up on, say and ask each other how you've been doing, and what have you been up to, what questions, so on and so forth. Okay, just don't share the actual code, but please do talk, okay, and catch up. Today we will just take the program that we wrote last class and try and modify that more. Okay. All right. So how about you guys just carry on a conversation of your own? Switch on your cameras, by the way. All of you who are here, just switch on your cameras so that you can start conversing with each other, and then we can start class in about 5 or 10 minutes. Unless you have a question for me, okay? If you have a question for me, just feel free to ask. And even when you're talking amongst yourself, you can basically say, hey, Anand, I have a question for you, Prof, come back. Okay, well, not come back, I'm going to be sitting here, but if you prefer, I won't be in your face. I'll just turn the laptop on. That's okay with me too. All right, so switch on your cameras anytime and start talking with each other for about 5 minutes. Okay, and then maybe I'll set a timer. What time is it now? 8:03. Okay, we'll start in about 5 minutes. Alexa, set a timer for 5 minutes.
5 minutes, starting now.
Thanks. All right, so we will do
that.
You're
very welcome.
All right, so we will start in about 5 minutes, and yeah, go ahead. Ajay, oh, that's a photo, Ajay. You gotta turn your camera, all of you guys, right? Turn your camera on so that we can see your faces. Yeah, that's great. Thanks. Also, please try to come to class at 8. I know it's harder, especially with the days getting colder. I don't know what we can do about that, right? Because even when I was teaching face-to-face on campus, I used to be in the lecture theater at 8 o'clock, and students usually start dribbling in at 8 o'clock, and it's usually around 8:05 or 8:10 that the classes are full. But now that all classes are, most of you are at home, and only a few of you actually have to be on campus. It should be easier to do this. Yeah, ask me questions or talk to each other. You're just sitting there and looking at the screen or looking at a notebook or looking at stuff and not doing anything. So feel free to ask questions. Ask me or your classmates and say, hey guys, what have you been up to? And did you finish the first quest, or and go on and like that. Hey, where's Susilo, by the way? Where's Susilo? Susilo, are you here? No, he's not here. Okay. Well, because I gave Susilo a short walkthrough on video last class, at the end of last class, most of you had gone, for submitting the first quest, because I know that in CS2A, a lot of students just get stuck not knowing what to do, off the bat, what do we do now? How do we do the very first quest and things like that? So I thought it might be useful to give Cecile a walkthrough. What would be nice is one of you can produce a 5-minute video of the walkthrough. Yeah, if you have a Mac or PC, just start screen recording, okay? Screen record, and then you go to the web Quest site, and then you go to Notepad or something like that, Notepad or text edit, create the very first program. That's okay, right? First program, it's okay to share the code. It's out there online in all the IDEs, right? So write the code in Notepad, save it, and drag the file, drop it into the circle, click it, get the results, and say, hey, that's how you do every single quest. Okay, every single quest is like that. Later quests, you'll have to submit 2 or 3 files, but the first few quests, you only submit 1 file, and maybe not. The second quest, you submit 3 files, maybe second or third. Yeah. David, you're about to say something.
I had a question about that. Yeah, because the second quest requires you to do 3 things. I mean, no spoil. I guess I spoiled that, but what I was worried about was I would make so many errors between the 3 different programs that I would run out of attempts by the time I finished.
No. Hey, how many attempts are there, by the way?
How many what?
How many attempts?
I don't know. I have no idea.
Okay, I don't know either. So okay, so you should just keep going on, submit as much as you want. You really can't overload it, because even if the server is overloaded, it'll automatically clone itself into multiple servers, so you don't have to worry. So keep going. And like I said before, the only thing that I try to discourage is mindless submission, not because it's going to overload the server and all. Okay, mindless submissions don't do any good to the student, because and some people are nodding because they understand what that means, but a lot of people don't actually understand, right? Because they think that the point of the quest is to just get past each one by hook or crook. Yeah, like in life, many people say, I need to get there by hook or crook. I'll do whatever it takes to get there, and that is total nonsense, because once you get there, you're totally stuck. You won't know what to do, and because you've not learned the right habits to make good use of your success. So in order to make good use of the success in life, you need to know that what to do with the mini successes you get at every stage. And if you don't get a mini success at each stage, and you basically just cheat your way through, then you're never going to know what to do with a big success. Alexa, stop. Yeah, well, we started talking already. Right. So the only thing I try to discourage is students from doing is don't just be a little mindful of what you're going to submit, and again, it's not with a view of fearing penalty, or I'm going to get docked for grinding and things like that. No, all of that is really just secondary. Even if people grind, I don't by default dock participation points here, right? Even if I see someone grinding, it's just a flag for me, and then I can take a look at their code and say, well, are they just trying to blast bullets so that they can open the first door and go through it or something like that? If that's the case, then I say, okay, well, you know what, that is bad. But most of the time, people, even submitting within a minute or so, many times within a minute, I actually look at their code and say, no, actually, they changed something significant here. Right? And it didn't take them a whole lot of time to make that significant change. It happened like in 10 seconds, because I submitted something, it didn't work. And even when it was grinding, when the system was testing it out, they already knew it was going to fail, because they knew what was wrong and they're going to change it. And even when it's testing, they've made the change so that before it comes back, they submit another file. I've seen so many students do that. They're perfectly fine. Okay. So yeah. Maybe I should just reword this whole thing about grinding. But there is no limit. You can keep going on and on, submit as much as you want. You can get all your friends all over the world to submit at the same time too. It doesn't matter. In fact, it's more fun when more people submit and they're all talking to each other on Reddit. You'll actually find it's a great deal of fun. Yeah. Later on, actually, here's a great idea. Later on, you guys will be starting companies and all, right? You guys will be starting companies, and you need to hire people, top people, and you need to go to recruiters and say, well, you know what? And recruiters are not, you find that for startups, unless you have an in-house recruiter and paying them a salary anyway, which means they'll be on overhead and all. If you're using an external recruiter, it costs a lot of money because you hire a person and you got to pay them the first month's salary or something like that, right? So if the first month's salary is like 15K or 20K, you got to pay 20K to the recruiter just for giving you that person, who might have reached out to you anyway if they'd known, right? So, but when you are in that boat trying to recruit people, I think this might be a great idea. You just say, anyone who wants to work at my company, just go start a tiger named Fangs. Okay, use this ID, first name, last name, first name underscore last name as your ID. Go and quest at a tiger named Fangs, and then when you reach red 9, your total consideration for hire, because you can seriously consider them if they've got to red 9. You can seriously consider them for a hire, not only because they've got the technical competence to get there, but also they would have left a trail on Reddit, right? First name, last name. You can go and check it out and say, well, you know what, this guy is technically strong, but also look at the way they're interacting with their classmates. Fellow learners, not even classmates, right? Because fellow people who are also trying to get maybe they're all of these people trying to get the same job, but this person is not trying to shut them out and say, well, I got an edge, I'm going to go forward. That person, he or she is actually trying to help everybody else trying to get the same job. So even though they're competent, we want someone who is a good team player. So isn't that a great point, right? And in all my years of hiring people, I have never ever seen a recruiter give me that detailed information, right? Saying, well, this person is not only technically competent, you can actually go and look at how they're interacting with the other people, right? And that's enough. That's enough for a hiring manager. At that point, my interview time with that person has potentially reduced from one whole day, which it might have taken one whole day and follow-up interviews and all, potentially shrunk from one whole day to 15 or 20 minutes, because I know I have a 360-degree view of them, and I only need to know, their personality and whether they drink coffee with sugar and things like that, right? So that would be the purpose of the interview when they come over, not to check them out technically, which you can never do, right? I have never ever been able, even maybe some people have, even with a great deal of effort, to completely scope out the technical knowledge of a person during an interview, right? Yeah, and I think that is the case. Even if you go to some of the top companies and they give you these problems to solve on the board, and they can probe your thinking only to a certain level, right? But not like questing, right? In questing, you can actually look at the way the person is thinking all the way through, starting from hello world, all the way until some really, really complex and challenging problems. And you can see how they're thinking, you can see how they're interacting with other people and helping other people. And at the end, you will actually have a very, very good sense of saying, that person needs to work for me no matter what it costs, okay? Get them to work, right? And that is a kind of thing. You can use this, okay? Hopefully questing will always be there. And so you can use these things to help you later on. Can we start coding? Yeah, well, unless you have a question, right? If you guys have a question about, hey, Susilo, yeah, feel free to switch on your camera. I was actually telling your classmates that you will be producing a walkthrough video, okay? Walkthrough video of the dropping, creating a file and dropping it in and getting the result back. I think it'll be very useful for a lot of people. I would like it if you do, but otherwise, other people can also do it. But since you already know how to do it, it'll be nice if you can produce. Do you know how to do it? Do you have a Mac or a PC? You just have to do a screen record, and then you can talk through the recording too. You can say, hey guys, now I'm going to create a file, save it. Don't forget to save it. Now, after you save the file, drag and drop it, and now click it and wait for the result. Okay, that's all. And I think a lot of students are stuck. Not just you. A lot of students in CS2A get stuck at that point. So, and in fact, a lot of students who enter my 2B and 2C without having done my 2A and 2B, they can also take a look at this and say, oh, that's how I get started. So please do that. And I think it will be very useful for everybody. Okay. All right. So I think we can code again today. Does anybody have a link to the code that we did last class? I believe it was, I think it was create a, yeah, it was to create a set of simultaneous linear equations with two variables, and then give the user a chance to solve it in their mind. Okay. And then they'll have to say, what is the value of one of the coefficients? Now, I think this morning I was thinking about extending it more to introduce some new features and looping and things like that. So it'll be more exciting. And I was thinking that you can also turn this into a game by saying, we're going to give you a pair of simultaneous linear equations, and you're going to solve it in your mind. And then we are going to find out how many seconds you took to solve it. And when you solve it correctly, it'll tell you how many seconds you took. Right. And so it's actually a game. You can play it with your friends, especially if you're doing algebra and all, right? If you're doing an algebra class, well, you guys are in college. But if you have youngsters in related to you, a kid brother or sister, and they're learning simultaneous linear equations in school, you can tell them, right, play this game. Okay, play this game, and it'll give you a very simple equation, all integer roots. Not in the roots, right? Now, we can actually do a quadratic too. Maybe next quarter I'll do a quadratic. Okay, so it's all integer. It's integer solutions, and it'll be presented to you, and you got to solve it in your head because you won't have time to work it out on a piece of paper. You got to solve it in your head, because solving these simple equations in your head is a very useful mathematical skill, just like writing hello world and simple programs in C++. Okay, and math is very similar. Yeah, I told you before, computer science is just a very specialized field of mathematics. Okay, so a lot of skills that you bring to bear in being a good mathematician, you can also bring to bear to being a good computer scientist. And so you can actually, in math, just like doing a lot of things, for loops and things automatically in your mind, simple problems in mathematics, like solving simple equations, linear equations, simultaneous linear equations, a lot of these things, you got to do many, many times. And one of the mistakes I made when I was a kid, right, when I was a kid in middle school, is that I got past all the exams because I knew how to solve these equations, the simultaneous linear equations, one time, right? Enough to get me marks. But the trick the important thing that nobody ever told me when I was a math student is that it is not enough to know how to solve these simple problems, because in school you're only learning simple problems in math. Okay, you're not learning to solve the Cauchy-Riemann hypothesis in school, right? Not in middle school, unless you're at Gauss or someone, okay, and totally flummox the teacher with some really complex shit. Okay, she's not going to tell you, okay, now you go and solve the Riemann equation or something like that. Okay, so but what no one ever told me is that these are simple things in math. And these are not meant for you to just know how to do so that you can go on to do some more things. No, these things in math are supposed to, even after you learn how to do this, you got to do 500 or 600. I'm not exaggerating, maybe just 100 or maybe even 20 or 30 for some people. Okay, but you got to do enough for you to force your mind, even without your voluntary effort, to force your mind to think about it when you're walking and doing other shit. Okay, so you're walking around, you've solved so many of these problems, you're going to keep thinking, well, you know what, of the 50 problems I solved, that 27th one was pretty cool and it was interesting and I couldn't do it. So why couldn't I do it? Okay, and you're going to be thinking about that. And that's all it takes, okay? Thinking about it a few times, involuntarily. When you start thinking about things involuntarily, those solutions will just become internalized when you find them. Okay, and the trick to being a good mathematician or good computer scientist is to take all these simple things and tell yourself it is not enough. It is not enough to just pass it, just to get the mark and move on. That does nothing at all to you. Okay, you got to keep doing it repeatedly. And as music, I don't know how many of you are music teachers, right? How many music teachers are satisfied if you just played one time correctly? Okay, so no, they'll say, no, keep on doing it again and again until you're totally solid. Someone wakes you up from sleep and gives you a violin, you say, wow, right? Like that. Okay, so you got to be like that. And that comes, right? For simple things, that automatically comes. And it's only practice. And that is why I think the 10,000 hour rule, I think many people have written about it. The one I remember is by Peter Norvig. Okay, Peter Norvig wrote this really, really cool essay, which was on the internet, saying learn some language in 30 days. Okay, and that I think maybe it irked him, because it irks me too when someone says learn C++ in 30 days. How many boot camps are there? Learn C++ in 30 days. Can you learn C++ in 30 days? No, right? It's impossible, really. I think, unless you're you already know a great deal of stuff. So, and so he wrote this essay. So no, you can't learn it in 30 days. You need 10,000 hours, okay? 10,000 hours. Even the Beatles, such a great band, they 10,000 hours before they produce their first hit, right? They were playing in simple bars, with 5 or 10 people drinking beer. They were doing that 10,000 hours before you get. So anything, practice for a long time. A practice is not meant to get to, and again, the distinction between practice and learning, two different things. People always confuse, I think, right? I'm practicing, I'm learning. No, are you practicing or learning? No, they don't know, right? Learning comes first. You got to learn, but after you learn is when practice comes. Well, many people say, well, in the process of learning, I practiced it enough. No, it took 5 hours to learn it, but that's how much it took to learn it. Now you need 50 hours of practice after that, or 10 hours, or whatever it is. Practice needs to come after learning, because the learning happens, learning transfers the material from outside into your brain, okay, into the conscious part of your brain, so that you can work it out when you're conscious, right? Work it out by thinking through it. Practice takes whatever is in the conscious part of your brain and pushes it deeper, so that it's not conscious anymore, so that your conscious brain can now be freed up to learn more stuff. Does that make sense? Now, all of this, I'm just spouting off the top of my head. It is not from psychology. I've not looked into research in psychology, so it may be completely wrong, right? But maybe some of you are going to major in psychology. So major in statistical psychology, right? Not just hand-wavy psychology, right? Statistical psychology is where people actually make many experiments, controlled experiments, and try to do these things and find out the p-values, and find out, okay, this is like a 99% certain to be true, this hypothesis and things like that. And maybe you do a hypothesis to say, well, I'm going to do an experiment in learning psychology, right? It'll be of huge use to educators and teachers everywhere in the world to say, well, I'm going to distinguish between practice and learning, when people tend to conflate the two. There should not really be any intersection. Maybe there's a small intersection, right? And so we hypothesize that when we learn, things go into this part of the brain, but when you practice, the same thing is being pushed down. And is there a way to test it? Is there a way to test it during MRI, fMRI, and things like that? Okay, those cool things you can do, all these experiments. And so, yeah, hypotheses all over the place. Okay, anyway, so nobody's taking the screen, okay? So I don't, hopefully not Aldo, not Samir, and last class, I think it was David. Was it David?
Yeah, it was me.
David, okay. David, so anyone other than the three of them, okay? Please take the screen. And hopefully not Susilo also. You got a chance, okay? You got a chance last class. Well, you get another chance later, but you did get a chance to code and things like that. Okay, you can come back later. So someone else, take the screen. Share, and hopefully that link that we created on, I think it was cpp.sh eventually. We went to cpp.sh and created a link and said, click that share URL, that URL there. That if you go to that URL, you'll get all that code from Tuesday. Does anybody remember what that URL is? Oh, it isn't, you can actually go to the YouTube video and, scrub it to the place where David clicked that link and it showed you what that link is. It's like 5 characters, funny characters there. So you got to, if you can get that URL, paste it. Otherwise, it doesn't matter, okay? Because we'll recreate that whole program, but we won't talk through that whole program one more time because we've already done it. So we'll be able to recreate what we had in 5 minutes. So if you had it already, we'll go with it. If you don't, we'll start with a blank slate and we can recreate that program in 5 minutes and then add on other stuff that we talked about today. And then we can also get to play this, okay? Hopefully we'll get a chance to play this game today. And because this week is this the week we're doing branching? This is week 3. Yeah, technically this week we're just still supposed to be talking about branching structures and we're already doing looping, right? So we have a lot of flexibility and time and freedom here. So we'll bring the code and play with slightly more sophisticated looping and branching structures in there. Add some bells and whistles, saying, okay, well, I'm going to look at the clock now, measure the time, and then I'm going to ask the user, what is the value of A, and give them and start counting my clock, 10 seconds, and then until the user gets the right answer. When the user gets the right answer, we'll say, hooray, you got the right answer, and you took 17 seconds, 18 seconds, and things like that. And then you guys can play that game, right? And say, well, you know what, I played it and I took 15 seconds. I played it and I get 17 seconds, right? So you can do that. And if we have time, I'll also show you how to create a leaderboard. Okay, so there's one program which can be played by many people. and it'll keep a file with top scores and the top 5 scores or things like that. And then when someone eventually wins, you can say, well, you took 17 seconds, but here's the leaderboard, you're 7th, right? And there's so many people who solve linear equations faster than you. And so that's really cool, right? So you can do that. Now, here's another thing you can do if you're a math teacher. I don't know if you're a math teacher. In 2B and 2C, I have a lot of math and computer science teachers. Well, not a lot. There's a few math and computer science teachers in elementary school and middle school who are learning computer science so that they can teach computer science to their students in school. Okay, so if you're a math teacher, if you're planning to be a math teacher, if you know math teachers, you can ask them to create, you can basically take the program we create today and create similar programs for them, saying, well, this one does simultaneous linear equations, but let me do another one, just simple linear equations, right? 4x plus 7 equals 12, right? What is x? And the person has to solve it in their mind and say the x equals this, okay? And you give them 5 or 6 attempts and they got to do it in their mind, right? Simple equations like that. And if you're doing for kiddies, right, elementary school kids, you can say, you make the equation even simpler and say x plus 7 equals 12. What is x? And the child has to, figure it out and type in, oh, x equals 5, okay? And they get multiple attempts. And obviously, you can keep a leaderboard and say, well, you took 7 seconds and 3 attempts, whereas that person took, 5 seconds and 1 attempt. So all those things are really, really cool. Okay, so you can do these things. And in fact, if we have time, I'll show you how to do those things in class today itself. Okay, change the equation and do these things. All right, so who wants to take the screen? Who wants to take the screen? Anyone, right? Other than the 3 who've already, it's a fun experience, okay? Ask David, ask Samir, ask Aldo. It is actually a fun experience to be coding all together and have the code spoken out to you and having the opportunity to type ahead a few times and correct it. It's great, okay? So don't miss out on these opportunities. You don't, you can go and shut yourself into a library room and code on your own in private, and you can compare yourself later on, right? Was that more fun, or coding in class with all my classmates? Was that more fun? Right? Why miss out on this incredible opportunity? Right? So everybody should get this opportunity. So please go ahead and click on an incognito browser window, okay, and private browser window, and we'll take it from there. And if anyone has managed to find the link to last week's code, Tuesday's code, please share that also, and we'll take it from the link. Otherwise, we'll just code everything today. Who wants to code? Yeah, David, you have a question.
I was gonna say, I can find that link. So when I copied it yesterday, so we had trouble. I had trouble with the first IED that I used. And so I had to transfer over to the one you were talking about. And when I went to copy the code to save it into a file, I realized that I copied the code from the IDE that failed on me. So I only had like 2/3 of the code that we wrote. And so I
even even that is better than nothing, right? So if nobody gets a code, whoever shares their window, their screen, just send the code to them via chat, and they can copy and paste.
Sure, I will.
We'll wait for Samir to settle down. He's walking. Andrew and Connor, you should also, just like everybody else, unless you're in a position or in a bus or something like that, you can switch your camera on. Feel free to switch on your cameras. Okay? Yeah. Thank you, Andrew, and Connor, you too. All right. Who wants to take the screen? Anybody who's not in a vehicle should be able to take the screen. Because technically you don't have to do anything. We're going to be doing everything together. You're not the only thing we're doing is, if you don't want to, you can just be a typist, conduit for what the class comes up with. You just need to type it in. Okay. Go ahead. Who wants to code? Alec, you want to code?
Sure, I can take the screen.
Yeah, don't be reluctant and hesitant like that, okay? It'll be fun. We're all behind your back. Okay, so don't because in your voice I noticed some reluctance there. So don't be afraid like that. Excellent. Okay. All right. Now David will send you no, you can delete the whole thing. David's going to send you some code. You can just paste it in there.
Yeah, if you want to just shoot me your email, like over
No, you can just paste it in chat. Just paste it in chat and we'll yank it from chat.
Oh, for sure, I'll do that. Yeah.
Oh, the only catch is that hopefully it'll be indented properly when you copy and paste, and because chat may screw up the indentation, but hopefully online GDB will put the indentation back. Let's see what happens. Did you get it? There you go. Oh, you shared the entire file?
I shared the entire file. I couldn't copy and paste in the, it was too many characters.
No worries. Yeah, Alec, you need to, yeah, there you go. Yeah, well, it seems to be most of it actually. So, oh, it's just missing the loop and all. Yes? Yeah, that's
it's
pretty...
just a loop, yeah.
Thank you, David. All right, that is really cool. And this, did you prettify this code afterwards? Because I don't remember the code looking so nice before. Did you line up things and so on?
I made sure to change the variables, or I changed like variables in lowercase that were originally uppercase in the notes up top. So it would correspond to the variables that I used for the actual functions.
Very nice. Thank you. Thanks. All right, good. All right, so now let's do the while loop. Let's do the loop. Now, there you go. Where line 42. Go to the end of line 42. Yeah, there you go. Enter. Yeah, where you had it is fine. I think there's one space left. You need to go one more space to the right. I think. Is that the default indentation? When you hit tab, that's where you got it. Enter. Oh, okay. So that's correct. That's fine. Okay. So it did indent correctly. So what we want to do essentially is put a for loop there. Do you guys want, so here, my question, do you want to do it with a for loop or a while loop? I can do it with either. If you want to learn about the while loop here in class, we can do it. But personally, I think the for loop is better suited for this particular loop. You can learn about the while loop later, and we'll have an opportunity to use while loops later on, okay? Next week, lots of opportunities. So my preference is to use a for loop. Unless someone wants, to use a while loop, let me know, and we will do it. Otherwise, we'll use a for loop. Is that okay? All right. So type in for, FOR, open parentheses. Yeah, and inside you're going to say int space I equals 0, semicolon. Yeah, space I equals 1. I'm sorry. I less than 10. I is less than 10. I'm so sorry, Alec. Okay, I is less than 10. Yeah, semicolon. Yes, it's I plus plus. Okay, that's a very standard for loop. Now, one of the things, we'll make that change later. Okay, and I was going to change something, but we'll make the change later when we get to it. Okay, so yeah, and space, and then no semicolon after the I plus plus, by the way. Okay, yeah, these are simple things that we need to get used to, because intuitively I would also have put a semicolon there, but the language says okay, no semicolon. So these are some things that we have to get used to. Right. So now we put a space and then an open curly brace. Yeah, enter. Okay, now this is the body of the loop. The first thing we're going to do is print the prompt saying, what did we say? Oh, we did print the 2 values. Okay, all right. What is the m times a? All right. Okay. So I was trying to think of what prompt to say. Yeah, C out, left shift. What is the coefficient of the first number? No, what is the first number? Not the coefficient. What is the first number? What is the first variable? What is the first variable in the two equations? Oh, in fact, we should say what is the value of A, right? Yeah, why don't we do that? Well, yeah, let's change. Let's do that. Okay, change no, you leave it there. In line 38 and 39, change the first number into A and the second number into B. I think it'll be a whole lot easier. Yeah.
Oh, oops.
B. Yeah. That's A. That's A. And this one's B. Second number is B. Okay. All right. Now you can basically say, what is the value of A? What is the value of A? Yeah. All right. Now space after the question mark. And then a semicolon there and enter. No, so space after the question mark, and then after the quote, you put a semicolon. Yeah, you got to put the semicolon after the quote. Yeah, thank you. Right, on the next line, you're going to read in what the user types in for their guessed value of A, right? So you're going to say cin, right shift into right shift, space, right shift. Right shift is 2 greater than signs. Yeah, right, into user input. Or user guess, call it user guess, And again, yeah, that's right, user underscore guess. Now, this is a variable, but we haven't declared the variable. We haven't told the compiler that we need a variable. So let's go to the beginning of the for loop on end of line 43 and hit enter. Now let's declare that variable and say int space user underscore guess, and then hit an enter after that. No, semicolon, right? So we got to get in the habit of any any statement we type in C++, we got to put a semicolon and enter. Okay, not like, do you have to do this in Python? I don't know why I keep forgetting.
No.
You jump between languages. No semicolon in Python, right?
No.
Right. So all right, cool. So now you need to put a semicolon after user guess on line 47. All right. Now I put two new lines there. Two new line. Yeah. Okay. Now what you want to do is if user guess double equals A, within parentheses. Now I have an idea. Okay, I have an idea, and you guys have to tell me if you guys are okay with this. Okay, rather than me calling out the code, would someone else, you know, not the whole thing until what we did last class, would someone else like the opportunity to call out the code for Alec to type, right? And I'll be here and watch, so that if you say something that is incorrect, or even if you say something that is correct but could be styled better, I might say, well, you know, I might jump in and say, you know, do that instead. But someone, because these are all the opportunities you need to go for, I think, right? Does anybody else want to call out the code for Alec? And I'll be here, okay? So it's not like he's going to get the wrong code to type in. Anybody want to do it? Or do you want me to do it?
Included a space after the if, between the if and the open parentheses. So that's
go ahead, Samir.
There.
Yeah.
Yeah, it should just be like the function should just be directly next to the parentheses of whatever you're gonna, yeah.
So all right, put a curly brace there and go to the next line. Curly brace, yeah, where you had that. Put a curly brace there, go to the next line. Right now, I'll tell you what you want to do, and you guys should, one of you can speak out the code for Alec to type. What we want to do here is basically, user has got it correctly. Yes. So all we need to do is say, hooray, you got it right, and you took this many tries. Okay. It needs to tell that to the user and then exit or return 0 or something like that. Okay. That's what it needs to do.
You might want to add end line as well. Left shift end line or end L.
Do I put that?
Yeah, after the
After.
hooray. Yeah, after the quote, and then do another left shift and then end L. So space, double left shift, yeah, and then end L. And then go down one line, yeah. And then see out again. I guess, or actually could have done, yeah, never mind, it's fine.
No, I think this is good.
I was just saying
I
you could delete the semicolon and then just go down anyways. And double, so if you delete the semicolon here and then go down a line. And then add the left shift in again. Then you'd add like your next, so it was like hooray, and then it took, what was it? It took how many I'm trying to remember if we have a counter or something.
I is a counter of the number of tries.
Yeah, okay, yeah. That's good.
The for loop.
So
Do I have to then?
You do another left
Yeah.
shift and then and then if you want to add more string, just another left shift after that.
and then just add the semicolon at the end of that one, and you're good.
Well, I also
Oh, and
want
then
to add spaces
the-
to the
yeah, yeah.
strings. Yeah.
I think that should be I+1.
You're right, yeah, it starts at 0.
Hey, who said the I+1, by the way? Someone said I+1 should be I+1. Who said
That was
that?
Joshua, I think.
Joshua, yeah, thank you. Yeah, okay. I was also thinking that, and exactly at the same time you said that. Now we're going to try and make it easier. Okay, make the fix this in just a bit. Okay, so and I think did someone say Endel or something? I don't.
Oh yeah, I did. I don't know. Were we not supposed to? Oh yeah, I guess it's just one thing, or
Oh, you just need to put an Endel at the end of that line. Left shift Endel. The one thing I tend to do, right, and I think this is probably not even the convention that Xcode or VS Code uses, is you have the C out and then the left shift on the next line.
There's a
What I do-
semicolon missing on line 50 after Endel.
No, that's what Will. So what Will said was, let's not use many different cout objects. We'll just use one, and then left shift lots of those into the same thing on different lines. So that statement on 50 continues on 51.
We could use one endel as well. You could replace it with /n and not flush the buffer every time.
Very
and then you
nice.
just have
Very
one
nice.
string, and then you don't even need to like the
you can delete the
/n is
yeah.
part of the string. So you just delete the two left shift operators between hooray and it took you, and or actually no, just one of them. No, wait, both of them. They're supposed to be the same string. Just like
after the exclamation point.
combine the two strings. Just after the exclamation point, like delete until it, and then just put /n.
Samir's got a typo in his chat.
Why is there the I+1 in the code?
Remove the left shift operator after \n, and then remove the quotes after hooray and before it. And then remove, yeah, there you go, that one.
Okay, just this is correct. Okay, I just want to make a stylistic change, and this may be completely different from according to, you can change these things later on. So here's what I do now. First, that \n, it's not /n, it's \n. And here's what I do. Okay, and you can think about it and see if it's right or works for you. Close the quote like you had before. Close the quote after the /n. Yeah, right. Now double quote. Now the other thing is that you see that space before the /n. You have a space and then a /n. Yes. Now anytime you have white space and then a new line, that white space is not going to be seen at all by the user. Yes or no?
No, it won't.
Yes.
So it's redundant. Asking the computer to do something that is not going to be seen at all. So get rid of the white space. Yeah. Okay. Good. Now go after that. There you go. There, exactly there. Break it. Get it. Take it to the next line. Take that to the next line. Take that. And I'll tell you why I say that, okay? Now put in 2 left shift operators there, because this is how you had it before. You know, this is how Will structured it the first time. Okay, now the reason I do this, and also the stylistic change that I follow is that you see the left shift operators, I line up the 2 left shift operators. So push the line in so that the left shift operators are in the same line. Now, one more. Okay. So the reason I do it this way is because when you look at it here on screen inside of the program, it is much closer to what the user will actually see when the program runs. Yes, because it's not all on one line. So it is always useful when it comes to debugging. Okay, because I've seen in bigger teams and product teams and all, I've seen so many things that the program is technically correct, but the user report comes in saying, well, you know, it's not what I expected to see, and we go in and look and say, well, the program is right, but the user sees something different. And I think many of those bugs we traced to the reason that the programmer, the code written by the programmer did not match the user's output as closely as possible. You can't do it 100% obviously because you have slash and all, but as closely as possible, reduce the likelihood that you have to deal with UI fixes later on. All right. Okay. Good.
Small thing, but I think you're going to want a space after the right before the T in tries.
Oh yeah. And see, that is also another thing. When you have these things like this, what somebody just did, you can run these things in your head because you can say, well, that's what it looks like. Let me see what it's going to look like in the user's computer. You'll be able to see that there was a space missing before the T and all, and it's very nice. Okay, now one more thing I want to do, and it's a cosmetic detail, but I think in my mind it's an important cosmetic detail. You see how you had to say I+1 on the cout line on line 51? Yeah, that is a problem, and it's a nasty thing. Okay, and it's nasty because the plus operator may have a different precedence with the left shift operator. We don't know. Yes, because if you go to expert programmers and ask them which one of these 2 operators has greater precedence, they'll probably have to Google it and find out, because these little details many times sometimes you forget. And so if you present this code to the compiler, it may actually complain and not even compile. One of you should try and compile it. May not compile because it says left shift the I, and then I got a cout operator, the stream, and then I have to add plus something to the stream. Doesn't work. Okay, and it may say the plus operator is not defined for a stream, and so why even run? And the other thing also, it makes programming easier if we now say, well, you know what? Let me make it a whole lot easier and simpler and more efficient by changing the for loop itself. So instead of going from 0 to 10, I'm going to go from 1 to 11. Okay, so change 1 to 11. Now you don't have to do I+1. You just say I. Right? So that's the only change you made. And now, not only did your compilation problem go away, your coding is also easier because you're actually telling the user your ith try, the first try, 1 try, the second try, and so on. You got the counter. You don't need to do any mishmash to the counter to get the actual try number. Okay, does that make sense? Now, inside of the for loop, after the cout statement, you want to also say return 0, right? Or exit 0 or something like that. Say exit 0, exit 0, exit 0. No, you had the under the cout, right under the cout. Exit 0. Exit is the same as returning from main. Okay, exit says leave the program and get the hell out of here. Okay, and no matter how deeply in the program you're nested, leave the program and go back to the operating system. That's what exit means, right? And in this case, it's going to be the exact same as return 0 because you're already in main. So if you return from main, it's the same as exiting from main. So it's the same. All right. Okay. So exit 0
about exit. I have a question about exit.
Yeah, sure.
And I noticed that in the second quest that you use exit and that it has a parentheses around it.
It does need to have parentheses around it. Charles, yeah, absolutely. Thank you. It needs to be fixed. It needs to have parentheses around the 0. Not there. No. Exit parentheses. Exit is a function. Okay. This is the difference between return and exit. Is that exit is a library function. Okay, it's just like print or any other function you may call. It is a function. Function needs to be passed parameters, right? So that's why it needs parentheses. Main is a function.
Would you also now need to include something else to use exit?
Actually, I don't know. I think, do you have IOStream up there? I think that should cover it because IOStream probably includes other files, and one of them may have exit declared. We'll try it. If it doesn't, we'll include the standard lib also. Yeah. Samir, okay.
Wait, were we missing the using namespace STD line, by the way?
Oh, are we? Are we?
I think we were when yeah.
Oh, yeah. Okay. All right. So you need to put that in. Put that in. Nice. I like what Alec is just doing by himself, putting spaces before and after and all. So these are all, many people just dismiss this as trivial things, not important things. I think, in my opinion, this is all super duper important. Okay. Just getting the hang of aesthetics of coding so that it's not in your mind all the time. Your aesthetics should just be automatic. Then you can focus on, it basically makes it easier for you to debug also later on.
I don't remember how
Let's
to.
just
Yeah,
get
somebody
names,
just
namespace.
what somebody just typed.
Let's see.
Namespace, type namespace. No, using namespace. You had using space, namespace, space. I always feel strange speaking that out. Using namespace, using space, namespace, space, standard. Okay. Okay, now you can go outside of the for loop on line 55, hit enter. Right, now you can say cout, alas, you exhausted your tries and you didn't get it. The correct answer was, right? And you can say, alas, you exhausted. You can say, you don't have to say alas and all. You can say whatever you want.
That should be outside of the for loop, no?
It should be outside of the for loop. Yeah. Thanks. Go back to your math book. Okay, math class. All right, good. All right, I like that. Okay, and then and add more if you want, and then what else? Oh, you need to also tell them what the right answer was. Okay, the correct on the next line you can say the correct answer was. Oh, yeah, on the same line too if you want. The correct answer was, and then the actual value of it. No. So yeah, and anytime you put a /n, close it and go to the next line because that's what the user is going to see. Yes.
Yeah.
Yeah. Anytime you do a /n, go to the next line.
You didn't close the first string. You need to put a.
Yeah. Thank you. Hey, I absolutely love it. Right. Okay. Because it's not every course, not every section, every class that I have these students just jumping in, just like this in it's happening here, just like on Reddit, where students ask the question, other students are helping out. Those are the things that make these lectures worthwhile for teachers, not for students. Well, even maybe for students, but the things that teachers actually like to see in class is when students help each other. Okay, so that is so much fun for me to see. And then, yeah, you need an and also. No, you need an endl after that. Okay. I think is that all? That's all, right? Yeah, I think this should run, shouldn't it? Yeah.
Should
Okay.
we like add a cout with within the for loop?
I'm sorry.
Should we add a cout saying like try again in a for loop?
Yes, I think that's a good idea. Who said that, by the way? Aldo?
I said that.
There's
Oh,
Joshua.
Joshua. All right, Joshua. All right, cool. Yeah. So what Joshua was saying is inside of the for loop before the exit. Oh, wait a sec. Oh, no. What is the value of A? Oh, you need an else. Okay, you need an else. What Joshua is saying is that right, Joshua? You need an else saying try again. So not there. You need after the if statement. The if statement concludes after the closing brace. Yeah, right. Now, the if statement doesn't conclude, but the if then part of it. else. No. You got else and then curly brace too, and then or you can just say else and return, because it's just one statement there.
Yeah,
You don't need no, else is not a function. You don't
else
need that,
doesn't take else doesn't take in like a boolean. It just
Yeah.
else is just if not if, then do it. And then you can add else if, which does take in a condition, but you don't need to have the condition in else. In fact, you need to not have a condition.
Yeah, I wanted to ask last class actually about the syntaxing behind if else in C++. Like in Python, if you're typing, like if you were to write an if statement, it would automatically assume an else statement afterwards. Like you wouldn't have to write else, you could just write your second conditional or whatever. Or actually you wouldn't write a conditional because else, whatever. But like you have to specifically write else in C++. Or
I'm pretty sure you also have to write else in Python. In Python.
I swear if
pretty
you
sure
only write one if statement and then you go to your, like you finish off your if statement, I can't remember actually, it's been a year, but I don't know.
I'm pretty
much,
sure.
I think it's pretty much the same. These constructs, these are basic constructs. They're pretty much the same no matter what language you go to. But I'll check. Maybe there's some syntactical difference there.
I successfully compiled a program that had an if.
Oh, you compiled it? Who was this?
Yeah.
Samir?
Yeah.
Oh, great.
No,
Okay.
Not this one. Not this one. Like I compiled a program with an if that had no else, and it was fine.
Okay.
No, you don't have to have else.
Yeah.
No, that's not what I mean. I don't mean that an else is never supposed to occur in Python. I mean that else.
So I might have worded it bad then. Sorry, that's what I meant. But
oh, even in it's the same. Even in C++, you don't need an else, right?
okay,
else
yeah,
is
that's what I was checking. Yeah.
Yeah, it is. But yes, that is right. So what Will was saying was that you don't always need an else. But if you do have an else, it's good to have the else statement there. Or you have to have the else statement, right? So all right. So after the else, don't put the curly brace and all. Just go to the next line.
I have a
I'll
quick
tell you why.
question. I have a question actually.
Mhm,
So if
mhm.
you just have if and you don't put any else at all, then if the if condition isn't met, then just nothing happens.
Nothing happens. Yeah,
Okay.
that's all. Okay. So if the condition isn't met, nothing happens. But if you have an else, then it'll do the else.
Okay.
Now, there is something called an implicit else, okay? An implicit else, and that's what we're going to do here. Well, we're not doing the implicit else. So an implicit else, we won't even go into this now, okay? Later on, in a few weeks' time, when we're coding something else, which is slightly more sophisticated, we'll have a situation where we have an if statement that has an implicit else, and I'll tell you, hey, remember the if statement? And I told you the implicit, that's what it is, okay? So, all right, so hit enter there, and then indent in, and type in cout whatever. I think was it Will or Adam said something. Try again. No, it was Joshua. Said yeah, try again. Yeah. And you need the endl and things like that, obviously. Yeah. Left shift endl. And in fact, before the try again, you can also say sorry, try again. Sorry. And later on, you can add frills to it, right? And say, sorry, try again, you have 3 tries left. Sorry, try again, you have 2 tries left. You can do all those things later on, okay? And in fact, after we've got the basic version working, I'll just turn it over to you and turn the laptop around to face the yard, and you guys can add those frills and these things, okay? All right, so that's all done, okay. Now, sometimes what people do is, we're gonna change this, to say put this after the else, put a space and then a curly brace, and we're going to remove it. I'm just showing it to you, right? After the else statement, put a space and a curly brace, and then after the cout on the next line, close the curly brace, just like you did for the else, for the if statement. No, and on the next line. Okay, and remove the blank line on 56 because the if and the else is one block. You want to keep them together. Okay, all right. So this is a perfectly good and natural, and lots of people do it this way. Okay, but in C++, if a for or an if statement has only one statement, not a bunch of statements. You see, for then, if in the then part you have 2 statements, right? You have a cout and then you have an exit, 2 statements, right? So if you have only one statement, in C++, you can get rid of the braces around it. So the function of the braces is really to make the compiler believe that whatever is inside the brace, inside those braces, just make the compiler believe it's one statement. Okay, so you can have a whole bunch of statements, and the compiler thinks it's just one statement. That's all the braces do. Essentially, it's a block. Okay, so right, so you can get rid of the braces now for else. You don't need the else, right? Or leave braces there and put a comment there. Put a comment there. Right. Put a comment. Yeah, put a comment. These braces are optional because else only has one statement.
Do we even need else at all though? Because exit, if that happens, it's already going to exit the program and it's not going to try and execute the sorry try again thing.
Yes.
Yeah, that's what
Absolutely.
you meant by implicit code.
Let's do it. Do we do it that way? Okay. So what Adam is saying is that why don't we just why don't we just bite the bullet and use the implicit else right away? Okay, not wait until week 7 or week 8. So what Adam is saying is that even though we don't have an explicit else statement there, because the then part will exit, right? It's going to leave, exit. So which means that if it didn't go into the then, it's automatically in the else. So you don't have to have an explicit else there. If it doesn't go into the then, it's all automatically in the else, right? It's never going to execute that part unless there's an else. So he's saying, Adam is saying, just leave out the else. And that is called an implicit else. There you go. We're not going to talk about that again in week 5 or 6. An implicit else means you can omit the else and still get the same behavior from the program. Okay. So, you know what? Leave the else there. We'll put one more comment. Okay. We'll leave the else there and we'll put one more comment above the else now. Go to the previous line. Go to the previous line. Oh, in fact, no. Go inside the else. Go inside the else. Inside the at the end of that line and hit enter, and let's put a comment inside. Okay. Yeah. No, indent the comment in. And say and bring it. Yeah, there you go. And you say, in fact, you can say, in fact, even the else keyword is optional. How do we say this? Even the else keyword is optional because it could be an implicit else, because it could be an implicit, right? And put, stars or quotes around the implicit to emphasize that, right? Put star on both sides or something like that. Okay. And then you can, on the next line, you can say, Google to find out what an implicit else is, right? That's homework for you guys. Right? Google to find out what implicit else is. Okay, is that okay with you guys? All right, now I think that is the basic program. Let's run it once, play the game. Now, after we've done that, I want to go back and do one more change before I hand it over to you guys, right? And the change I'm thinking about is before you enter the for loop, we're going to look at the clock, okay, the system clock, and find out what the time is. Okay, when you come out of the for loop, before the exit, meaning successful exit, you're going to look at the clock again. Okay, and then we'll say, well, you know what? Before the game started, that was the time. Now the time is this. So how much time did the user take to solve this problem? This minus that. Yes? So we'll do that and also additionally print that message when the user succeeds. So we'll know how long they took. Okay, that's the first step. We're not doing the leaderboard and all. Later on, I'll show you how to do the leaderboard. Okay, so all right, so try again. That should work. That should work. Someone try and compile it, or even Alec could compile it himself. Run it. We can see it run. Okay, now can you increase the size of the console, the black console? Just increase the size of the console. And also, I think there's a UI issue. Why is there no space after the question mark? Did you put a space after a question mark on line 47 or 48? Yeah, kill the program. We'll restart it because it doesn't take a long time, right? So space there. I think that's it, right? Everything else checks out. Okay, run it now. Okay, I have selected 2 random numbers between 0 and 9. 5 times A plus, A, the times is missing. 8 times B. Yeah. Right? So let's go and fix these things. Yeah, times B. And also, I have selected 2 random numbers A and B between 0 and 9, right? So I have selected 2 random numbers, comma, no, two random numbers, comma, A and B, comma. Okay, all right. Now if you run it, I've selected two random numbers A and B between 0 and 9. Yeah, between 0 to 9. All right. 3A plus 2B equals 2. 4A plus 0B equals 0. Wow. Okay. Now we know already what the value is. Okay. All right. So yeah, that should be 0, right? So hit enter and you should say, hooray, it took you one try. Okay. All right. Good. Now run it again. Hopefully we shouldn't get any 0 issues, right? So 0. Okay, now that's more interesting. Okay, that's more interesting. Okay, so now let's see if we can solve this. 2A plus 1B equals 18. 5A plus 1B equals 33.
Is a 5.
10 plus 8, and then 5 plus 5, 25. Yeah, okay, it does work. Who said 5, by the way?
It's me, Will.
Wow. Okay. All right. So yeah, Will is working these things out in his mind really quickly. Okay, 5 is the right answer, but let's not put 5. Okay, let's put because we want to know. Yeah, Samir. Adam is already topping the leaderboards. Okay. So yeah, 3, and let's see if we get alas and things like that. Yeah. Sorry. Try again. Keep trying. Try a few more, and then. You're gonna get 10 tries, okay? So let's push that to 10 tries. Keep giving wrong answers for 10 and see if it actually gives you that failure message at the end.
Can we try putting something outside of the range? Like, what if we try and
totally,
put something from, like, what if we put like 10? Because
Yeah,
if it's limited to 0 to 9, we should also limit their answers from 0 to 9.
No, but Adam is saying doesn't matter. It says because once you've opened up the console to the user. Good programmers. I'm not talking about bad programmers. Good programmers, when they give control to the user, they are prepared to take any damn thing the user says. Okay, and this is something that I've had to coach many newbies on early in my career. Okay, when they give control to the user, you have to assume the user can say anything. Now, I've seen poor programs where the program will work if it's given the right input, but sometimes the user will give the wrong input. And the program doesn't even know what to do. It'll crash, segmentation fall, or some horrible thing happens. And then I say, why, this crash in the customer's hands? Why would that happen? And they say, well, you know what? No, the program is correct, but the user gave the wrong input. That's why the program crashed. Okay. And I usually tell them, no, that, beginners always do that. Experienced programmers will make sure that the user is never wrong. Even if they give you the wrong answer, they are not wrong. Okay. So what you have to do when the user gives you the wrong input is to take it and not die, right? And they never die on the user's terms. You die on your own terms, right? You say, no, I can't handle this, dear user. Give me some other number. Okay. This is the range where I can handle. That range I can. So that is good. Okay. Good programmers do that. Bad programmers will say, oh, I don't know how to do this. I'm going to die. All right. So that's so we don't do that. So type in 99, 89. Yeah, there you go. It looks like you need to go back to your math class. Okay, that's awesome.
Can you
awesome.
type
That's
in
okay.
like a string too? Because like it's not just numbers that can be wrong.
Yes, totally. Go for it. Type in FIVE. All right. Yeah. All right. Yeah, I don't know. All right, okay. That is so cool. All right, now who can explain what happened? Okay, now this is really cool. Okay?
Yeah.
And I'm so glad that Adam asked that question. Okay, because it gives us an opportunity to talk about something really important. Okay, really important. And I'm glad this is on video, and hopefully you can summarize this in a post on Reddit for other students and other programmers too, right? Don't have to be our students, because there are real professional programmers out there who are making this error. I know, right? I've seen these programs out there. So why did that happen? Why did the loop basically just zip through after that? You gave it the wrong input, and then it zipped through. It didn't pause for the next CM. It didn't pause and say, the last one was wrong. Try again. Why didn't it do that? Can someone tell me that? Because it's very subtle. Very subtle.
So it's taking each of the characters in the string and inputting that as the guess.
That is a very good guess. Who said that? Nemo, you said that?
Yeah.
Okay, that is a fantastic guess. Okay, that is what I would have also guessed, but that is not the right answer. All right.
No.
The right, you'll find the right answer obviously when after you find out why the guess is not right. But that is a very good guess. Someone else take another guess. Okay.
So I'm not sure if this is what it is for sure, but I do know that if you do CN, it only takes the first word as input. So when you put in I don't know, you're giving it 3 answers.
Mhm.
I don't
Take-
know
oh,
if
yeah.
that's related to this though.
That is correct. Yeah. Again, that is also a very good guess. So what Adam is saying is that CN will take the first word. Okay. It won't take the rest of the stuff. And then the next scene is going to take the next word. And the next scene is going to take the next word. That is correct. That's exactly what will happen. However, if you notice, the loop went through 10 times, not 3 times.
Right, which is why I wasn't sure about it.
Yeah.
because-
Okay. Yeah. All right. Good. Good. So you
I
know
wanted
that's
to-
I love this. Okay. I totally love the discussion that's happening today. It's never happened in any previous class.
Does it have
you know, every
to-
time you're always looking for new stuff, and this is so cool. So we're getting closer now. Why? So is what Adam said. If what Adam said was in fact the right thing, why didn't it stop after the 3 words? Why did it keep going for 10 words? So
Does it have to do with
Go
the
on.
fact that each character is like represents a numerical value?
I'm sorry. Each character is a
Like represents a numerical value? Does it have something to do with that?
No.
No?
So
Okay.
what Nemo is saying is that it's not reading in word by word, it's reading in character by character, and it's got more than 10 characters. That's what you're saying,
So
right?
I think I know what it is.
Go for it, go for it. Even if you
we're-
don't know, that's
We're trying to put a string into an integer.
fine. Okay, and why would
and
it screw it up?
I would assume that that would screw it up because it's trying to convert this string to an integer, and it's doing the best it can, and it creates like probably a bunch of just integers that are just the values of the characters, maybe.
Can I add on to that?
Sure, absolutely.
I think or what I remember is in C++, string is in its own library. It's not built into C++. So if you don't explicitly tell it, hey, this is string, you'll assume it's a consecutive characters, I believe, or that's what I think. That's why
Yeah, it's a
here
character
we don't
array.
yeah, we
it-
don't explicitly say it's string, so it breaks down whatever input we have into character, and that's why we have 9 loops, which is 9 letters. They skip the spaces because what Adam said earlier, like the CIN doesn't really take space, it'll take it as like a different like it will skip the spaces and then just take the next character. But that's what I'm guessing. It's being processed as characters because we don't say string anywhere here, so it doesn't understand it as a string.
So that is also, you know, I keep thinking every time someone gives a guess out, and I think I keep thinking that's a fantastic guess. There's no more fantastic guesses left. Okay, but Aldo's reason is also really, really cool, and it's a very nice one. And it so happens that we can actually scientifically test out what Aldo just said. Okay, there is a scientific test, you know, empirical test. That's what it means, right? An unscientific theory is something that you cannot test. Right? If you say there's an invisible pink elephant in the sky, you cannot test it because really, right? You cannot. It is not a scientific statement because if it is invisible, it's not pink. Yes, because it can be invisible and pink at the same time. So it's an untestable theory. However, if you say there's an invisible, there's a visible pink element outside your door, you can test it. You can go, open the door and say, hey, I've never seen a pink elephant before. Okay, so you can test. So this is a theory that can be tested, and if you can test it and say that is true, that is false, scientific. Okay, otherwise it's unscientific. So there is a very nice test we can do to verify or disprove what Aldo just said. Okay, can someone tell me what the test is, or I can do it right now? It's going to be fun. Okay?
Don't we just enter in an answer with a different number of characters and see if it outputs the same number of?
Fantastic. Yeah. Thank you. Right. I'm not even telling you most of these things. You guys are all just coming up with the right answers. And that is so cool. Okay. So yeah, type in, there you go. Okay. So now that is actually enough information for Aldo. right? Because Aldo produced a theory that says, it's going to read all these things, but you don't have 10 characters there. There's only 4 characters, but still it did the same thing.
Oh, I was just gonna say it's a bit of a coincidence that for both of our inputs that we put in here, the number of characters that we typed in was the correct answer for A. It was 4 and 9. Like right now it's 4 and we typed in test and it was 9 before that.
No, I don't think so. I don't think it's a coincidence. Run it again and just type A
Oh, is
or
it
B
not?
or one letter. And in that case, it didn't, even though it got 4, it didn't say you won the game, right? It failed.
Well, no, but I'm saying it says the correct answer for both of our things. It was the amount of
Oh, the correct
characters that we
answer.
had in our value. Yeah. For A.
Well, not this time now.
I mean, not this time,
Not
yeah,
this
but like for the 2 that we did, it was, I thought that was funny.
All right. So now we have the data that, says, all those excellent guess was actually incorrect because, it doesn't work. Okay. So there is a very subtle reason that technically I don't expect you to know at this point because it needs a little bit more experience in C++, but I might as well tell you because you'll understand the reason. It's just that you won't encounter it.
The only thing
Anybody
I can
wants to
think
take more
of
shot?
is maybe it's like creating a pointer or something to a string.
No,
that
no,
it's
no, no,
creating.
don't worry.
No,
Yeah.
okay.
Don't worry about pointers and all. Okay, pointers week 10. Let's not even think about pointers until week 10.
Okay.
Anybody else want to take a crack, or I can tell you? No? Want me to tell you?
No, don't tell us.
Okay. All right. So here is the actual reason. Okay. Now C out is a stream, or C in. C in is a stream that connects the keyboard to you. Now, did you create C in your program? No, it's given to you, right? It's a global resource. It's a global resource in the C++ library. It's been created for you automatically when the program started, and you were just handed it, right? You were given a global resource and asked to play with it. Yes? Now, this global resource can be configured in different ways. You can tell it, give me an integer, give me a string, give me this, give me that, and you point it to the source. And so in this case, you've pointed CN at the keyboard and said, give me an integer from the keyboard. So all that CN sees is a pipe leading to the keyboard, and it is expecting an integer to come through because that's what you told it. You said, there's an integer coming in, read it and put it into user guess. Yes? Okay. Now it's looking down the pipe and it's not saying an integer. It's saying a character, which is not an integer. Yes? So the way that CIN is designed is that if it's connected, if it looks in a pipe and it sees bad input coming through the pipe, unexpected input, it is programmed to basically say, this pipe is probably not the right pipe I'm supposed to be connected to. I'm going to mark it as a bad pipe. Okay. When you try and read something that CN is not able to, the operator is not able to provide you, it will mark the stream as a bad stream. From that point onwards, all reads on that stream will fail. So when you try to put in a string, the CIN object basically just got flagged. It got marked as saying, oh, this stream is not connected to numbers. It's connected to characters, not what we want. Okay, so it became a bad stream from that point onwards. You cannot read from it.
If we want to fix that, we could do string stream. We could replace CN with string stream and use that to parse the input first. And instead of assuming it's going to be an integer, and like that way, if we give it a string, it's not going to crap the bed and terminate the program by saying our terminal is not a good pipe.
Absolutely right. So that is exactly what we have to do. That is exactly what we have to do. And if you do that, you are safe, because the way we've written the program now is a newbie program. It is not user safe. Okay, it is. There's a saying in engineering: you can make a product foolproof, but you cannot make it damn foolproof. Okay, so there's always bound to be people who will break your program, no matter, right? But what Adam just described is a way to make the program damn foolproof. Okay, well, it's not total damn proof. Only they could hit Control C and shit like that. Okay, but you're fortifying the program. You're making your program stronger by doing what Adam said. Do you want to do it now? I can show you how to do it now. You guys want to do it now, or
I
is it
figured
gonna
we
be?
were gonna do it during the frills stuff. So if we're still, I mean, if we're tackling this is like the biggest issue of the program, in my opinion.
Okay, well, why
I
don't
don't
we
see
do
a
it?
reason
All
not
right.
to do it now.
Okay, all right. This is probably the best place to do it too, I think. Yes. Right. So why don't we do it now? Right. So we're going to change the program so that it doesn't crap out when the user gives it wrong answers. Okay. And so let's go back to the top of the program where you have the cin statement. All right, here, there's two things we're going to do. So after user guess, after on line 46, hit enter after line 46. Yeah, enter. And then here, you're going to say string space user underscore str. Okay, so we're going to accept string input from the user, not numeric input from the user, because anytime a user types in, you can't expect them to, right? So now where you have the cin statement, we're trying to read something in. Where is it? There you go, right? Now there, no, you want to go to the previous line and hit enter, actually. So enter. There, you want to say I string stream, all one word, okay? I string stream. And that stands for input string stream. Now, that is a class. It will manufacture your own copy of a stream, which you can make behave exactly like Cout or Cn. Yeah, now it's an input stream. So it's coming into you. So it must come from a file or a keyboard. What we're going to do is, it is a string stream. What that means is that give me a stream that is actually coming from a string, not from the keyboard. Okay, so in other words, when you read from the string, it is not going to read from the keyboard, but it's going to read from a string that you've used to populate that object. Okay, that's what we're going to do. And so I string stream space, and let's call it something, right? We'll call it is. Call it is, little is, right? And then open parentheses. And then we need the user guess. Okay, so
We
you
also
need to triple click. Sorry, go ahead.
We also need to include string stream or s stream at the top, like where we're doing as.
Yeah, but yeah, absolutely, Adam. So we'll finish this and we'll do that. Okay. Yeah, that's absolutely right. Okay. Hey, Alec, cut line 50 and put it after the cn statement, right? Yeah, triple click there, triple click, and Control X or Command X. No, Control X. Oh, it doesn't do. You don't have these hotkeys, right?
The shortcut wasn't working for some reason.
Oh wow. Oh, it's a Mac. You should say Command X, not Control X.
Yeah,
even
that's what
working?
I was doing it, and it was rejecting it.
Oh, okay, all right. So go to the next line. Go to the next line. Hit enter after CN. Yeah, hit enter. Now paste it. Indent it properly. Now, a few things you need to do. Now, where you say cin to user guess, we know user guess is an integer variable. Yes. So change user guess to user str now, because you're going to read into a string. And we're going to do one more thing, okay? So one tiny thing, and it'll make a huge difference. Now, when you read in a string from the user like this, it is going to do exactly what I think Adam or Aldo said, okay? Or maybe Joshua. It'll only read the first word. So if I don't know, it'll only read the I. And the rest of them will still be in the buffer. So the next time you do a CN, it's going to get the next word. So we don't want to do that. So instead of CN, we're going to use another way of getting input from the user, which is called get line. Okay. So go to the previous line on 49. On 49, hit enter. And you're going to say get line, GETLINE. No, one word. Get line is a function. Okay. Get line. And then open parentheses. And we got to tell it, where do you get the line from? Get me a line from CN, right? So CN is the first parameter, comma, and then you got to give it another parameter saying, well, I got something from CN. Where do you want me to put it? Get it from CN and put it in a variable that I have got called user underscore str. right? Okay, now put a semicolon at the end. Now that statement is a nice statement because it'll get the entire thing the user typed in on the line up to the new line until they hit enter and give that to you. It gives you the entire line. Okay, now the reason I like get line is because in the user's mind, always, when programmers need to think about the user all the time when they're programming. In the user's mind, when they hit enter, they've given you the whole thing, right? When they hit enter, they're not just giving you the first word. Yes? When a user hits enter, in their mind, they've given you the whole thing. If that is the case, then we have to read the whole thing to minimize confusion. And get line will get the whole thing, right? It won't just get the first word. Now you can try later on in your own time without using get line. You can say, cin right shift into user string, and you can see how this program will fail. Okay, because it does things that are unexpected. But we're not going to do it in class and waste time. So now you got the user string. Now we're on this next line on 52. We're going to make a stream from that string. Okay, and so pass that stream as that string as a parameter to is the constructor for the string. So inside of the parentheses is, right, you say user underscore str. Okay, and a semicolon after that. You want to put comments there saying, yeah, okay, we'll put comments there just in case, to help students. So yeah, at the end of line 52, yeah, open a comment saying user, you want to say make an input stream called is. Yeah, thank you. Which will take the place of cin, which replaces cin for us, which it doesn't replace cin, which we will use instead of cin, which we can use instead of cin.
And we need to get rid of that cin right shift user str line to line 51.
Absolutely, yeah. So triple click and delete that line. Yeah, you can delete that line. Okay, now where you have on the next line after 50, what is it, 51? Yeah, after 51, paste that line again, Yeah, paste whatever you deleted. Oh, you deleted, not cut. Okay, so see, so you want to say is greater than user guess. Is, yeah, right shift into user guess. Okay, now that simple change that we made is so powerful because it says instead of just reading a number from the user, we're going to read the entire string and then parse that string. Oh, hang on. User string. I think that'll work. Okay.
The semicolon, no, after user guess.
Yeah, thank you, semicolon. Yeah, well, so I think that greater than will take care of the parsing and get you the numbers and everything. You can get rid of the blank line. We can run it now and try it with the problematic inputs and see if it behaves the right way. Oh, hang on. What does it say? Oh yeah, of course. What Adam said before. We forgot to include what does that include file?
S-stream.
S-stream.
Yeah, it's just here. I'll put it in chat so we can.
No. He's got it. I think S-stream. Yeah. There you go. Yeah. Right. I think it should compile and run now. Okay. Great. Okay. Now let's give it some problematic inputs like ABC and all and see what happens. No. Oh, because A is 0?
No, I wrote test and said hooray.
No, that means A was 0. Wait, hang on a sec. Is A 0 then? Is that why it worked?
Yeah, that does work.
Yeah, because A is 0. So we got to figure out a way in which A doesn't get set to 0. In fact, go to your program. We'll make sure that number 0 doesn't get chosen. Okay, 0 is getting too easy. Some people will luck out and win the games. So where we say ran %10 You say add one to it. Add one to A. Yeah, plus one, and add one to B also. Now, do we need to add one to M and? Oh, why are we getting 4 variables? Yeah, we do need 4 variables. Okay. Yeah, I think that's good. We don't need to add one to the other 2, I think.
Yeah. Now the range changes in the comments. The range changes, right? To
oh yeah.
1 to 10.
Comment. Yeah, fix the comments. Fix the comments. 1 to 9. And also, I think in a cout statement, you also have that number in a cout statement somewhere.
Would it be 1 to 10 or 1 to 9?
1 to 10, because now you get 9 returned from the modulus operator, but you're adding 1.
Yeah. Okay.
Hey, one more place. There's one more place where you had 0 to 9 or 0 to 10. There. I see it. Line 40. 1 to 10. 1 to 10. Okay, now I think it'll work. Okay, so if you go back and
Yeah, it worked.
yeah, now let's try and solve it though. Let's see who gets it first. 9A plus no, it's 120. Well, I'm trying to do it the hard way by basically guessing in my mind, but the easy way is to basically do the math thing and say, add up the equations and all. Can we do that? 6 and 9, finding the multiple, lowest common multiple is going to be. What can we get? 9 times 9 times 90 plus 12. 9 times 90 plus 12. Okay, so if B is 10, A is 2, does it work? 18 plus 80. 88, did we get 88?
It's.
Oh, I see. Yeah, hit OK, and then copy the whole thing into your clipboard. Command A and copy the whole thing into your clipboard. Just to be safe, okay? Is it copied?
Yeah.
No, your hotkey wasn't working. You have to hit right.
Yeah,
right
it
click
did. It worked. It seems like it worked that time, but yeah, I'll do that anyways.
Okay. All right. So run again. Maybe that was a temporary blip in your. Oh boy.
It's just the same thing that happened last class.
That's so
wasn't it?
funny. But that last class it wasn't. Last class it was David and so it's
I think
not
it's just the
it's
website.
server, it's a
Yeah,
remote
if you
server.
refresh the page, shouldn't it be fine or no?
If you refresh it, we'll lose the code. Yeah, refresh it.
But if we
we'll
already
get a new
copied
connection.
it, right?
Copied
Yeah.
it, yeah.
You can just refresh it and then paste the whole thing back. Command A and paste. Yeah. Okay, run it now. Oh, you actually have 2 blank lines before the return. That's yeah, okay. Right. So save it. No, run it. So let's try and guess it now. This should be easy. This is 53. 2A plus 7B equals 53.
A is 9, right?
49 and 3. 49 and 2. 2 and 49 maybe. I don't know. Try 2. I don't know. Maybe 2 will work or not. Well, let's try the second one. 2 and 40 and 2 and 7, right? So 49 plus
Isn't
12.
9?
Yeah. There you go. Okay, all right. Now it works, but actually, there is a great deal of scope for fun here because it is. I was actually running it through in my head really fast, trying to come up with a solution before one of you guys and Adam or someone beat me to it, right? So I could actually feel that sense of competition there in my head. Yeah, this is actually really cool. Now let's put if you guys are okay with it, we'll put the timing thing. So it it took you this many tries and this many seconds. Are you guys okay with that? Oh no. Or you want to take it? We don't have to do it, okay? If you guys want, what time is it now? Yeah, you got a half hour before the end of class. Do you guys want to play with it without the timing thing, or do you want to put the timing thing? There's only 2 lines, okay?
Adding timing would be cool.
Yeah, I think so too.
Okay. All right. Good. Thank you. Right answer. Right answer. Okay. All right. So let's go before the for statement. Where you go? Where's the for statement? Okay. There you go. Line 44. Line 45, hit enter after line 45. All right, now what we want to do is say time _t, right? time underscore t, which is actually the exact same thing as a long integer. Okay, so in fact, instead of time t, you can say long. Okay, so you can say, oh, or we'll put a comment. We'll put a comment and later on. Okay, so time t space. What do we call it? Then call it. Call it then. Call it then. You'll see the reason for it. Okay, then equals time, open parentheses, null pointer, close parentheses.
Like spell out null pointer.
And NULTR. Now put a semicolon after that, after the closing parentheses, and then let's put a comment there, and saying time is a function that returns the current clock value, which is stored in a variable called then, right? Shorten that sentence, right? Time, we say time is a function and all. Change that to just time open close parentheses. That will save us some space. Open close, and then lowercase t. Lowercase t for time, because it's a function, right? Time returns the current clock value, and then which is stored and all. Yeah. And then put a period after value and say we store it in then. We put it in then or something like that. Yeah, okay. All right. It's still, I think, that 80 columns line, it's going beyond 80 columns, but you can fix it later. Yeah, we store it in then. Yeah, in a variable call, and you can get rid of the variable call and all, right? Because that's all pretty obvious. Okay, all right. Now, what we want to do is just before the exit, line 50, line 59. In fact, before you go there, copy that line 46. Copy 46. Triple click and copy. Yeah, copy that. And then go to a line before the exit statement. Before the exit statement, hit enter. Yeah, there you want to paste it again, but instead of then, you're going to call it now. Right, and then you can get rid of the comment now because people know what time does. Right, and on the next line, you're going to say a time. No, you can say unsigned. Just say unsigned long. Unsigned long. Diff for difference. Diff equals diff, right? Diff equals now minus then. Now minus then. Okay, semicolon. Now let's put now on the previous line, time t now. This should really be on the previous time where we had the time call. Yeah, we'll put the comment here. Okay, put a comment there saying time t is just a synonym for unsigned long. You can time t just a synonym. Yeah, is a synonym for unsigned long. You can use interchangeably. Can interchange. Can interchange. You can interchange. Yeah, can interchange. Okay. Now after the place where you calculate diff, go to the next line after that. Enter. Now you can say see out. You took this many seconds, and you can say diff seconds.
Can I make it into two parts, like you took, and then put the number?
Yeah. I think that's the only way you can do it.
Unless you're doing printf, yeah.
Yeah.
With cout, you have to do separate.
No, not unsigned long. Unsigned
diff.
long is just to tell the compiler when at the time. No, you need the left shift. And then you just need to right shift diff. Yeah, left shift.
Unsigned and long are keywords you can give when you create like an integer. Long means, I think it's what, 15 bytes.
16.
16.
No, long is 4 bytes. Yeah, for 4 bytes.
Or 4 bytes. Right. But like long is like the biggest integer, and you can do like a long. I can't remember how many that is exactly, but it's enough that
Eight,
you're.
I think long
Enough.
should be 8. I've never used a long in my,
Yeah,
in my life.
you're not gonna need
but,
it. You're not gonna need it. But unsigned makes it so it's only positive. Remember how we were talking about that 2's complement and everything? It just
Mhm.
doesn't worry about that. It's like just 0 to the highest number it can make.
Got it.
Okay, cool. I think that's basically it. I think it should run. Hey, Alec, it looked like you had a lot of fun, typing. Is that right? You had fun, right?
Yeah, that was good.
Cool.
Good practice.
That's what I said, all right. So if you run it now, it'll also tell you how long it took. Okay, so I think it will be a great deal of fun to play this game with, let me see if I can get it fast. All right, times 71. Wow. Okay. So I think that the
Is it 9 again?
is it 9? 7, 9, 63. 63 plus 8. Is it? Oh,
I
geez.
just lost the connection again.
Yeah. Paste. Oh, we lost the equation. Okay, we'll get a different equation. Hopefully, an easier one this time. All right. So when you run it, we'll hopefully get an easier equation. Oh, gee, your server, the server is not being reachable. I think that's what's going on. Or at least the internet connection from you to that machine is gone. Go to cpp.sh. It's usually a little bit more.
Do you still have the code copied? Do you still have the
Yeah.
code copied? Okay.
Yeah, you have to copy that code. Yeah. Okay. I think this will run. Hopefully, right? We'll see.
But where's the
run button?
Where's the run button? Oh, execution.
No. There's a run button. There should be a run button.
It's on the
somewhere.
right. It's on the right. Yeah.
Oh,
Bottom right.
my
Bottom right,
Zoom
sorry.
window was covering it.
Okay, there you go. All right. 5 times a plus 4 times b equals 85.
It's 9.
Wow. Okay. 9 seconds. Who said 9, by the way? See, you got it right.
That
in
was
9
me. Will.
Yeah, wow, that is cool. Well, you got it in 9 seconds and 1 try. Okay, so I think this is a pretty cool game that you guys can actually play in your spare time. Between classes, you can just sit down. Well, if not you guys, certainly I think if you have little brothers and sisters, they would absolutely love to play this game. I think, hopefully, right? I also get them engaged in math because math also. A lot of people just think that it is actually a great deal of fun once you get past that mental hurdle that says it's not for me. The only reason I find that people are not having fun with math are the people who think that math is not for them. Okay, they just make up their mind. It's just like people too, right? When many times when people I've met, right, many people, two incredible people, they could have incredible conversations with each other and they could enrich each other's life in excellent ways. But for some reason, they make up their minds about other people without knowing anything about them, right? Based on their appearance, based on the way they look, and once people have made up their mind about someone, no amount of empirical data about that person will ever convince this person that person's actually good. Have you seen that? You'll encounter many people like that, where their minds are made up not based on data, but based on something else. And you can present any amount of data and it's not going to change their mind. So like that, that is what I find with math. Okay, many young people, in my opinion, every single kid out there, every single child is automatically, when they're born, they're set up for math. They can do math. Okay, and the ones that they are not interested in math are basically just because of external people they encounter saying that math is this thing, you can't do it, go for something easy or something like that. They make up their minds about math. But if you don't do that, if you happen to be in a family or in a place, in a society where they don't make you feel intimidated in front of math, you'll actually go and try it out, right? Everybody, even a candle that could burn your finger, if you watch a child go and put a candle in front of a child, it's going to go and try and touch the flame, because it's out there, it's yellow and bright, and it's got a blue center, and it's dancing all the time. It's going to try and poke it, right, until it gets burned. And so no matter, even if it's something dangerous, children are naturally drawn to it. And so only when people say, no, that's a flame, it's going to burn you, they don't go near it. Okay. And math is like that. It's really beautiful. And not just math, okay, anything. They're all really beautiful, and people don't do it because some silly notion has been put into their heads, not explicitly even, sometimes implicitly, just by watching people around them. Silly notion. This is not for you. And they don't question it. And they don't, never discover the joy. So the first thing to do to get the most out of life is to first abandon all the silly notions that people have put in our heads. And say, well, or at least question them, saying, why is it that people are telling me not to do this? And then when we start questioning things like that, we discover that, wow, so many things that I could have actually used to enrich my life, and I never did that until now. And then you discover these things, right? So math is like that. I'm pretty sure if you take it to youngsters and have them play this game, they'll have a field day, right? They don't even, they can actually do this in a library too, right? If you generate a cpp.sh link, and they can go to any library in the world, right? Halfway across the world. You can go and type in that link into a browser in China tomorrow, today, now, right? You just email this link to a friend of yours in China or Russia or anywhere in the world. They can play this game right now, okay? So, and that is so cool. So I think did we do a decent amount of new things today to keep you? I know Alec had fun. Everybody had fun today. Okay, everybody's had some fun. That is really cool. And did you all learn something new and interesting and useful today in class? Great. Okay, now we have some time left. We have about 5 minutes left before I'm pretty sure Nemo has to go, or someone people have to go. But would you like to just chat amongst yourself? You can even take this 5 minutes to play this game or add more bells and whistles to it. Even if you want to stick around and do more programs, that's all perfectly fine. Okay, I won't stop the recording until you guys are done and the last person goes. So and Walter is still here. Thank you, Walter. Okay, so Walter's here too, and we will be happy to answer any questions you have. But would you like the last 10 minutes to just play around, either with the program and people can feel free to start drifting off to other classes. That's okay, right? So
yeah,
thank you all so much.
I have to go to my next class now, so, but thank you guys.
Well, share the link so that people who want to stick around can play with it on cpp.sh. Yeah, and also share the link on Reddit, okay? Because
how
next
do I
class
get a shareable link? Oh,
click on that.
Yeah, I got it.
Although next class we won't use this program anymore. Okay, that's it. Oh, next class we're supposed to do looping. Oh, well, I'll try and think of something else. Okay, well, or you guys can come up with some other interesting looping problem, and we'll do that next class. Maybe next class what we can do is do something that involves some interaction with the user and back and forth, some animation kind of stuff. Is it possible? We'll see. Okay, so next week we'll do some more fun stuff, hopefully, but not this program. Okay, I think this is okay, and you guys can take over and play with the program from now on. Okay. All right. Have a good weekend, coding weekend. Okay, keep coding and enjoy. And I will hope to see you all on Tuesday. All right. I'm going to be here for the next 10 minutes. Call me if you need me, but hopefully you don't. Thanks, Walter.
Yeah, of course.
See you Thursday. Oh, see you next week.
See you next week. Have a good one.